How are you today, Jordi?
I'm fine, excited to be here. A little bit nervous, you can imagine, but very happy to answer everything you know or everything think about Easy. So let's start.
Mm-hmm. Yeah, I mean, I'm excited too. What a coincidence. Yeah, I mean, I guess what do we want to start with?
Well, maybe we can start explaining a little bit what's Easy. Just very few words if people don't know yet. Easy is it's just an initiative for mainly connecting rollups in a synchronous way. So the idea is that we have a lot of rollups running, and probably it's going to be more running on top of Ethereum. And right now, I mean, they are kind of independent. I mean, they are like chains that they go by their own, but it's like they don't talk with each other, or they talk via some bridge, most of the time centralized bridge, it's one side and the other. So the idea is just trying to have this dream that from one rollup, you should be able to call a smart contract in another rollup in the same transaction, the same way that you would do it if you were in Ethereum mainnet or if you were in a single chain. This is a dream, and this is very much what we are trying to build on Easy.
When did you first decide that this dream is important to you? And like, what made you realize that?
Well, I mean, this is a dream probably, I would say, probably I realized, of course, from the first roll-up, it was a problem that exists there. I would say that during many years, I mean, since the roll-ups, I was thinking that this was, if not at least very difficult, or if not impossible. And I was thinking always more in an asynchronous way of connecting. It's probably the more natural way. I mean, you just send message from one chain to the other. But it's recently, and this is in the last year, we have seen that the evolution of ZK has go so high that, I mean, at this point, for example, we are able to prove blocks in real time. So I mean, the capacity and the speed of the provers are becoming so high. And then it's like, okay, we have this. With having this, do we really can achieve this goal? And well, it's when you start thinking about that, and then you realize what are the problems, and well, you start putting the pieces together, and you realize that this is actually possible. And this is very much how Easy was born, but was because we are in a point in time where ZK proving is mature enough and evolved enough so that we can build those proofs really fast.
Can we maybe walk through like some of the components of Easy, right? So like one part is the proving, another part is like what kind of interaction you're actually trying to enable. Like what is the difference, like say, between Easy and like say, just having one existing rollup? I mean, like whether like Base, for example, you know, they recently announced that they actually want to go to stage 2. Like what is the difference between just that and what Easy is offering?
Well, for connecting rollups, one of the things was said is that you need like a common trust. I mean, if you have one rollup and that's have their own sovereignty, and I have my rollup that's have a sovereignty, we need some common thing that we trust on. Okay, so this is not different in Easy, but the idea is that this common thing is Ethereum. I mean, this is like so the settlement. I mean, everything. So what the truth is what is in Ethereum set. Okay, and this is probably the biggest difference. And the other is okay. So we need. Rollup A and rollup B needs to agree in something that's atomic, that's something that happens at the same time. So this needs to, so we need to prove to Ethereum that you are doing your thing and I'm doing your thing, and that we trust one each other. Okay, so this is the possibility is that we can take the part that you need to guarantee, the part that I need to guarantee, and we can create a single proof that Ethereum trusts. And that's not only valid for 2 chains, but this is valid for as many chains as you want. Okay, so creating a single proof in the same transaction where things happen in Ethereum, this is probably what makes the things more different in easy.
So this requires a lot of integration between the L2s that adopt it, right? Because if one L2 has its own proof system, another L2 has its own proof system, then like both of them need to accept these merged proofs that you're creating. So how do you accomplish that?
Yeah, let me explain you a little bit what we have in mind. So Easy is not going to be linked to a single proof system. So in Easy, it's people will define. So everybody will be free to define their own proof system. Maybe ZisK is going to define a proof system, but SP1 can define their own proof system. So it can be ZK, and it can be even proof systems that are not ZK based. I mean, it can be a multi-sig proof system, could be, or a T-based proof system. I mean, at the end, it's somebody that checks that something is correct. And then each rollup will be free to choose which proof system they are trusting. And not only that, but rollups could choose maybe 2 proof systems or 2 out of 3 proof systems. So in one side we have rollups, in the other side we have proof systems, and it's the rollup who will decide which proof systems accept. Okay, so in Easy, when a block in Easy that all these interactions happens, it's not going to be, well, of course, if we have 3 rollups that affect 2 proof systems, it's going to be as many proofs as proof systems are. So one proof system will prove, so a proof in one proof system will prove everything that needs to be proven for the rollups that affecting. Okay, but a proof system will aggregate all the proofs that comes from different chains that they share the proof system. Okay, and it can be many proof systems there. So at the end, the block will, the last transaction will guarantee that all this, so that each rollup is doing the right thing, and so and nobody will be, so that nobody will cheat. Okay, and important to understand that the interface between rollups is a very simple interface. The rollup, of course, it's a state transition function. Every rollup can define the state transition function that they want, but when they are talking to each other, at the end is a single call. A single call return. So it's like, okay, you do whatever you want in your state, but tell me what are the calls and what are the returns. I can give you a little bit more details if you want, but it's like this is the main idea. If you want, well, okay.
Yeah, that makes sense. I guess, okay, maybe, yeah. So there's 2 ways potentially for, different L2s or even for L2 and L1 to talk to each other, right? One is synchronous communication, which you've been talking about. And the other one, which is much easier to implement, is asynchronous communication, right? So I create a receipt on one chain, and then I import the receipt into the other chain, I prove it, and then you can use this to send coins back, to do a lot of things, right? So you're doing a lot of extra work to make this synchronous communication possible. What are the benefits? What are some unique applications that this enables that just a purely asynchronous approach to rollups talking to each other would not enable?
Well, there is of course, there's a lot of applications, but imagine transaction. You are buying, maybe you want to buy a ticket, a plane ticket in one chain and contracting an insurance in another chain and maybe booking a hotel in another place, and all this needs to happen atomically. I mean, if you want to do that asynchronously, you could, but do that synchronous. It's so easy. And I mean, if we can in DeFi. I mean, it's like you want to have some liquidity in one chain. Maybe you want to move funds in one chain, take a flash loan in another place, convert, do something in there, send it back. I mean, it's like the idea is that we are in the same chain. I mean, we call it economic zone, but at the end we are in Ethereum. That's the idea. So everything is, so a lot of applications. I mean, identity, maybe it's a chain that's dedicated to identity, and then you just...
well, I mean, this one's tricky, right? Because with identity, like, you can prove it asynchronous when it's probably fine.
I mean, asynchronously, you can do things, but asynchronous also requires you have like two problems. One is timing, because asynchronous you need to send things, you need to be sure that so you need some synchronicity part, because I mean you need to send something and the other needs to receive. Yeah. So you have some time limitations, and then you have some atomicity, complexities limitations. Yeah. Probably you can solve it, but the complexity that you end up adding at the application level is higher. Here we are maybe adding some complexity at infrastructure level, but at application level, things become much easier because it's just a single call that's happening, and that's it.
Right, okay. So I guess, so to kind of re-summarize so far, right? So you have this framework which L2s can join, and if they join this framework, they specify a list of proof systems that they trust, and then you're able to create, I guess, a merge block that contains like multiple L2s, that contains transactions from each one, and the transactions in one of these merge blocks, they're able to like poke into both of these L2s, and I guess also into L1, and like basically do like any complicated interaction between all of them, right? Okay. So I mean, this is cool, and you know, there's lots of use cases for this in DeFi. It makes the programming environment easier. One other place that where this makes things complicated is who builds these blocks, right? Because one challenge I can imagine is there's going to be some users that wants to make synchronous transactions between A and B. There's going to be some users that want to do it between B and C. There's some users that want to do it between C and D. And then once the TPS goes above, like 5 or 10 transactions a block, you get to the point where there's like enough overlap that actually you start to get into something where it makes sense for just like one guy to make everything, and like it can't really work any other way, right? So how do you imagine the economics of this playing out? Like, who builds the blocks? What motivates them? How does this not become a monopoly?
Yeah, I mean, this is probably the hardest, I would say, this is probably the hardest question on that. I would say that this is not very different than what currently happen in Ethereum. Right now, Ethereum is built, I mean, most of the Ethereum blocks are built by builders, which are, I mean, I think there are various in Ethereum, but they're becoming more centralized in there. So probably, I mean, the easiest answer is probably builders will end up, because it's one they have an economical incentive. But it's important to mention something that's common with builders. Or we call this figure of, we call it composer. Composers is the one that are taking all these transactions from different chains and composing them together in a single bundle of transactions, and then send it to the builder, and the builder just creates them. It's important to mention that at the end, the owner of an Ethereum block is neither the composer nor the builder. It's the validator. So validators, they are still the final owners. I mean, they have the last word in deciding who is the builder or who is the composer, or at the end, what transactions they want to include in their block. Okay? And probably this criticism of centralization which is real. It's important to ask also the validators and the responsibility of the validators for keeping the chain working and keeping this decentralization. So at the end, the validators are the ones that are choosing the builders, the ones that are choosing the composers, and are the ones that are deciding what's happening in each block. And this is, I think that it's important to understand that this is the final, I mean, the incentives are in the validators in the last resort, on the last chance.
Right. Okay. So basically, yeah, the kind of building in all of these L2s would essentially, yeah, just become part of the L1 block building market, and whatever solutions apply within Ethereum would apply for everything across the EEZ. Okay. I guess, okay, another question. So one reason why people like L2s sometimes is because L2s have extremely low block times, right? So Ethereum, it has 12 seconds, and now, Raul is doing really crazy, amazing peer-to-peer stuff, and so maybe it'll go down to 8 or 4 seconds over time. But like Arbitrum gives 250 milliseconds, right? Or even lower now. And like it's not possible for Ethereum to get to 250 milliseconds without becoming centralized. And so if these blocks also, I guess one question is, like, obviously if these blocks have to be synchronized with L1, like if building these blocks is part of L1 block building, then like you cannot have block times that are shorter than 1 Ethereum slot, right? And so the question is, like, is this a problem? Are there ways to get around this problem? Are there ways for the EEZ to have faster block times? Is that something you have to like choose against composability? Can you have both?
I mean, you can have a smaller. I mean, you can have a lower block times, but you will have to trust something else or somebody else. I mean, you can have a centralized sequencer, and of course you can build blocks that are 3 seconds, and then every block you put 3 blocks at a time in Ethereum. That's perfectly valid, but then you need some mechanism to guarantee that whatever it happens in the middle is done in the right way. Okay, so block times is each. So what's a block? I mean, in an L2, that's probably it's a question because there is no consensus there. But you define how you sort the transactions in there, and if you can say what's a block, and another thing is that all the pre-confirmations debate, I think this is orthogonal to all this. I mean, if it's at some point we have good pre-confirmations in Ethereum, this may have some impact in the composers and on easy here that could accelerate. I mean, that could have like lower block times in there. But the interesting part is the part that, okay, so you are in an L2 and you are doing some transactions, but at some point you have some transaction that depends on something that happens in L1. And it's like, okay, what happened in the while? I need to block, I mean, I need to do something, okay? It's a kind of the example of decentralized databases. You have like, I would say, 2 options and another that's in the middle. The first option is you lock the chain. I mean, okay, so I lock the chain while it happens in L1, but then I need to be sure that L1 is final. So maybe I need to lock. So having high finality in L1 is always a good thing. The other thing that I can do is accept that it's going to be reorgs. So it's like it's the optimistic way. I mean, one is the pessimistic way, the other optimistic way is, okay, I'm just mining blocks, but I know that if L1 reorgs, I will have to reorg too. So that's the other way. And the other is, instead, there are other in-the-middle things. That's something like, instead of locking the full state, so instead of locking the full L2, you may partially lock. I mean, you may lock some pieces that affects one the other. Of course, this is something to explore, but I mean, for example, there are some possible solutions. Again, it needs to be explored, but you may have like, imagine like I have like 2 chains, one that's more I mean, the normal chain that's quite fast and doesn't block, and another that's the synchronous one. And then because you control, in a centralized sequencer can control both, you can play with that. But again, this is this mix that's like locking part of the chain. That's the other part. Okay. But both are options. Both. I mean.
Yeah. Okay. Maybe like let's say I want to understand better like how this looks from the perspective of like either a developer or a user, right? So like let's say for example, to use the use case, which I think you mentioned planes and hotels, and I think this was the train and hotel problem from like 10 years ago. Like I remember I talked about it. I think Andrew Miller actually came up with like that framing all the way back then. So like let's use it, right? Like let's say for example Base joins the EEZ, and let's say Base gets a deal with Eurowings, and Eurowings is now selling plane tickets as NFTs on Base. And then at the same time, like some hotel chain, like decides to like sell bookings as NFTs on O1, right? Then both from kind of my perspective as a user, like where I want to buy both of these atomically, or even the perspective of like a developer, kind of what the smart contracts look like what is the experience like? How different is it from programming if just all of these things were on O1?
It should, I mean, from the user perspective, they should not notice any difference, like if all these contracts, if all these people, they were in L1. Yeah. So it's like, okay, you do a transaction. Of course, you need to build all the logic, all the smart contract logic for all this, which is probably not easy. But if you were able to build in L1, you should be running in L2. With the difference that the L2s, they can be more sovereign. I mean, they can be. You can do a fork in an L2 easily, or you can extend. Yeah. In an L2, you can have like a precompile that's doing something specific, or even you can. I mean, chains are sovereign, so at the end you have the flexibility for these entities to run each one and give the security warranties specific to each chain.
Yeah, I guess like as a smart contract developer, right? Like if I were to build this on Ethereum, I would say there's a function and it makes two calls. The first call calls buy from the plane contract. The second one makes a call to the hotel contract, and then it checks did both call 1 succeed and call 2 succeed. If one of them fails, it just reverts everything, right? So. What's the equivalent of that here? What does the actual function look like?
Well, it will function exactly that. I mean, it will execute that and it will revert. So it will go to the state and it will guarantee that exactly works exactly the same way that currently Ethereum works. I mean,
so does that mean every object on Base sort of gets a virtual address on Ethereum, or?
Yes, the idea is that, in Ethereum, so a smart contract in another chain will have a proxy address, but will be a representative. It will be a representative of that smart contract in that chain. So interacting with that proxy, it would be equivalent that doing a call in that chain. If that call reverts, this will revert. If that call do another call to another chain, this will also happen. And at the end, the state of both chains will be modified according to the calls that happens here. And this is what the ZK guarantees that happens what it needs to happen in each chain in this call. But from the user perspective, they will see like a normal call that if it's happening in the same chain as Ethereum.
No, that's very nice. Okay, so the other concern that L2s might have, right, is that this involves really tightly coupling them to Ethereum, including from the perspective of verification, from the perspective of trusting proof systems, And like recently we've been seeing, for example, like Arbitrum saying like, hey, we're actually proud of having a security council that it can override things, and like we're not going to stage 2. We're going to just like use the council where we need. There's a lot of people who are saying like, well, maybe like we should embrace the overriding, and like maybe this stuff will never be secure enough. So what is your case to L2s why like actually like they should embrace like tightly integrating themselves with proof systems? They should embrace being willing to trust all of this technology and be more tightly connected.
But just to be clear, two chains that one is trusting one proof system and another chain that's trusting a different proof system. Both of them, they can talk one each other normally.
Okay.
And the guarantees are correct. Just to give you the idea is, so when there is one call between one chain and another chain of a different proof system, we call it's kind of a record of things that I prove and things that I assume. Okay? And in the other chain, you have a proof record, which are things that you assume and you prove, which is exactly the same.
Right.
Okay? And the hash of this is passed to both proof systems. Okay? And both they need to agree that this interaction between two chains are exactly the same. And this is what guarantees that the interaction between the chains is correct.
Right. Okay, so one technical point there also, does that mean that like basis proof system, for example, like if let's say you do this between like base and like Arbitrum, basis proof system would need to like understand and be able to walk over Arbitrum execution?
No.
No. Okay.
No.
Okay, so potentially base does not need to know anything, and like potentially Arbitrum could kick out the EVM. They could say we're stylus only, and like base doesn't need to know, and it all connects.
Yeah, and not only that is that all the chains should be able to synchronize themselves without having to go to the other chains. This involves a little bit of unoptimal things, because in the data availability, all these interactions, you need to store them. But this is what gives the guarantee that the chains are sovereign. You can have an RPC server following one chain, and you don't need to worry about the other chains. You can, and this is an important thing to keep the sovereignty of the chains there.
Yeah, I guess, okay, maybe the question to zoom in on is like, who is making the decision to trust, right? So like, for example, let's say you have base, you have Arbitrum, and in this example, like say both join, but they're keeping different proof systems. Even to make it harder for ourselves, Arbitrum kicks out the EVM, they're just doing WASM with stylus. Then who, like when you have one of these like merged calls happen, right? You have something happening in a base block. Based on that, it calls into Arbitrum. Based on that, some WASM is happening in Arbitrum block, then it calls back, and then based off of the response to that, something else is happening in base, right? So like who actually needs to make the decision of like, I am okay to make something inside of me on the base side actually depend on what's going on in this Arbitrum system that base does not understand at all?
Base will have a roll-up smart contract where we'll define this smart contract will define the properties of the base rollup. This will include the proving systems that they are using, which ones are there. Also, the upgradability of these proof systems, who can change that. I mean, it can be a fully decentralized if they don't want to upgrade. I mean, they will be sovereign for what is base related. Arbitrum will have the same thing. I mean, their own rollup with their own proof systems, with their own rules and their own things. Okay, and the interaction between them, this is what's proven in the smart. I mean, in the smart contract. I mean that both are following in the protocol. They are following the standard. So it's like, okay, I'm doing this. I'm assuming that the call to base returns this, and the other is proving that in the base is proving that this call was returned this way, and the other way around. So all the calls are. So all the interactions are proven assume it, prove it in both sides. I mean, in one side you are assuming something, in the other side you are proving something.
Right.
But we agree in exactly the same, what we are assuming and we are proving in each side.
Right, right. Oh, I see. So it's like on one side you have a list of sort of what the outgoing calls and like basically, you know, like what the sort of, you know, like the outbox and the inbox, and like the outbox on this side has to match the inbox on that side, right?
Exactly.
Okay, so I can see how like, you know, like I wants to try to sort of understand this by attacking it, right? So like let's say, yeah, for example, actually, yeah, let's flip a coin. Which one of these two proof systems is going to break? Who here wants the basis proof system to break? Okay, a few hands. Who here wants Arbitrum's proof system to break? A few more hands. Okay, so not my decision. But my decision is to ignore and flip your decision. So we're going to say basis proof system breaks, right? So if basis proof system breaks, then basically an attacker will be able to make a block that just says whatever they want, right? And so they will be, from basis, like from the perspective of base, they'll be able to sort of like make the outbox have a bunch of calls that says like, hey, look, Vitalik's account is sending all of Vitalik's meme coins on base to Justin Sun. You know, look, the USDC contract is printing 1 trillion USDC and giving it to this totally new character called Justin Moon, and like, you know, keep going, right? So then on like, I mean, presumably, even like if this happens, right, then like Arbitrum itself does not break, right? But if you want to have this equality, then like Arbitrum is still going to record in its inbox that all of these weird calls like that are sending totally like things to, you know, like to Justin Sun and Justin Moon are still happening, right? Mm-hmm. So why does this not kind of break things on the Arbitrum side?
I mean, Arbitrum is accepting that an external call return, and when this happens, this is, I mean, this is, I mean, this is assumed that this is happened. But imagine a user that's only working in Arbitrum.
Right.
I mean, this user should not have any problem. You have no way to steal the funds of this person, because Arbitrum is doing the things correctly. So Arbitrum, and if Arbitrum is interacting with other chains that are not doing anything crazy, this is continue work. Of course, if you are an Arbitrum and you are calling something in base, and base is doing some crazy thing.
Right. I see. So basically, yeah, if I'm sort of a normal Arbitrum smart contract, then I would just like see a bunch of these like random incoming calls from a bunch of crazy addresses I don't recognize, and like, if my stuff is secure, I'll ignore that, right?
Yes, I mean, we will have calls to smart contracts and they will return fancy things, but okay, this is going to be, once this call is done, okay, you are just accepting that this is what returned, because it was proven in the other prover that this was okay.
No, again, this makes sense. I mean, basically, yeah, you know, you have this sort of minimum layer that kind of allows these calls to happen in a standard way, and then beyond that, it's like, each individual application, each individual contract's responsibility to say, do I also trust Arbitrum based with this proof system, or like Optimism with this other proof system?
Exactly.
Yeah. No, it sounds like a good architecture.
This is very much like trusting a specific smart contract. I mean, if you are calling a smart contract that's malicious, I mean, good luck.
Yeah.
It's not so much difference than that.
Yeah, okay. So maybe just to kind of take a take a step back from all of this, like, back to applications again. Like, what kinds of applications are you personally most excited about enabling with this that cannot happen with just everybody going on base, and also cannot happen with like everything happening on L1?
There are many. Probably I'm more technical, and probably the things that I'm excited. For me, for example, one of the things that I'm very excited, but it's not very representative. But for me, is, for example, one is the extending extending Ethereum. I've seen, for example, a lot of applications. So I want to add this precompile, this fancy precompile that's validating this, I don't know, with this elliptic curve that's doing whatever. Or I want to add this zk thing with whatever that would be great for doing something. Or I think that, I mean, applications that are very specific, that right now running them, decentralized applications that are running in Ethereum, they are very expensive, or they are not viable, or they are difficult. Now they have a chance to build, like, to extend Ethereum. I mean, to have their own chain, to prove that they are okay and live there, and at the same time interacting with the rest of Ethereum.
Yeah.
And this is, again, I mean, this is probably what I'm more excited that this will allow Ethereum to extend, to prove new things, to experiment with different, I mean, with different primitives, different ways to work, different chains. This is probably what I'm very excited. I'm probably not the right user. I'm more a developer. But again, I mean, here is, we can talk about, for example, I like a lot, for example, all the voting systems. I mean, voting systems, they require a lot of, say, cryptographic primitives that in Ethereum, it's quite expensive to do that in Ethereum there. So having a voting system that's running in a decentralized chain with thousands, if not millions of votes, and being secure by Ethereum, I think this is, for example, one of the applications that I'm excited. But many more. I mean, there is like a lot of, we talk about this insurance, and talk about DeFi, of course. There's a lot of things that can happen there. It's a lot of applications, identities, things that, I mean, loans. I mean, there is a lot of applications that will unlock this in future markets. I mean, it's like a lot of things. Micropayments.
Yeah. So what's the first thing that we in Ethereum lands can expect from you guys?
We are, I mean, currently we are working really hard in what we call the smart contracts. Smart contract plus, let's say, I mean, all the documentation, I mean, all this standard part. The cool thing is that because we remove out of the question all this proving system, that means that the smart contract should be relatively small and relatively easy. And the idea is we want to release like a first draft of this smart contract, and we want to have that running in, let's say, we want to run it in mainnet because this is the way to test things, especially with the bundles and so on. Yeah. But it's going to be, let's say, experimental, something that's in mainnet but is not like production ready, let's say that way. And we want to do that very soon, the coming month. We are preparing in DAppCon, I think it's in Berlin next month. We are preparing some workshops to explain more detail how this works. And from there, we'll see. But the idea is to have like a couple of chains running there, maybe one new chain and something that maybe it's like something like a Gnosis chain, but more kind of a copy of a Gnosis chain running there. And we'll see, and the idea is maybe other chains will join this idea and try to stabilize as much as we can. Of course, there is a lot of work in the proving system, needs to be done there. It's a lot of work to do, but this is the, we are, I would say that we are all in. We are a lot of members putting this thing together, and I hope that we can see that up and running. We have some proof of concepts working right now. So just a matter of cleaning up, putting these things, and launching the smart contracts. And, want to open a little bit in the community and see and listen for ideas in there. Yeah, that's a little bit the plan that we have.
Yeah, makes sense. I guess, and then on the other side, like how big is the long-term vision? Like, is there anything that calls itself an Ethereum L2 today that you think would not be a good fit for EAZ?
No, I mean, the other chains. So, and we are trying to keep easy as flexible as possible so that all the chains should be able to adapt. They should keep the sovereignty. Of course, if they want to connect to other chains, they will have to follow some protocols, of course, but these protocols should be very minimal, and that's what we are trying to put in place. Simplifying. I mean, the idea is we want easy to be as simple as possible. You saw that it's not that easy, but I think that from conceptually it's quite easy, and we want to keep this simplicity as much as we can. And probably the difficulty of the project is how we make it simple.
Right, and it's so like it sounds like the only thing that NL2 would need to agree to, right, is like this, like this standard for inboxes and outboxes, right, and then like actually running the calls if they match up, right?
Sorry, yeah.
Like the only thing NL2 would need to sort of actually agree to is like this mechanism of these inboxes and outboxes, right, and running the calls if they match up.
Yeah, it's like how do you process the calls that come from other chains?
Yeah.
And when you are doing a call to another chain, well, you can do that. I mean, it's how you decide that.
Yeah.
But again, I mean, NL2 does not even need to be an EVM. I mean, it can be a WASM VM, or it can be something that's very specific. It's only these calls.
Can it be Bitcoin?
Can be Bitcoin?
Yeah.
Why not? I mean, you need to define, the thing is how you call Bitcoin and how Bitcoin calls to you. But if you define the way, at the end you define the state transition function where you accept calls and you make calls, you should be able to connect to easy. Okay.
No, thank you very much, Jordi, for introducing eEasy. I'm very excited to see where this project is going to go over in the next couple of years.
Thank you to you.
Yeah.